Okay, let's do example 2 from lecture number 3, the leveling lecture. We didn't get a chance to get to that today in class, so I wanted to work it out for you here so you could use this as another example to prepare for your homework and understand differential leveling a bit better. So let's go ahead and get started with this. And again, let me get my pen set up here. So this is example 2. Have a problem? Here we go. Example 2, lecture 3, which is a leveling lecture. So what we have set up here is a diagram of a differential leveling exercise where we have two different level setups, and we also have some intermediate sites in the process, and we depict or capture the location along this profile view, which is what you see here. This is a profile view, and you see this measured in stations. So let's go ahead and set up our leveling notes so we can get going here. So we're going to have a station. We're going to capture the back site, height of instrument. We have intermediate sites in this case, foresight, and elevation. And again, as we talked about in class, an intermediate site and foresight are basically the same thing. It's a site forward to an unknown location. We use the term intermediate site for a point where we're not going to change the location of the level afterwards, and a foresight is what we use when we're talking about a turning point. But essentially they're the same thing. So let's go ahead and get started. Let's start with the known location, which is benchmark 61, which is right here. And we're given that the elevation there is 189.08 feet. Now we set up our instrument or our level right here in this location, and we look back to the location of known elevation, which is the benchmark, and we have a back sight reading here of 4.72 feet. And therefore we can determine that the height of our instrument, this setup, is going to be the elevation at my benchmark plus the back sight, or a value of 193.80 feet. Now let's move to station 0 plus 0, 0, which is right here. At station 0 plus 0, 0, we have an intermediate site, intermediate site of 4.42. And therefore our elevation at station 0 plus 0, 0 is simply going to be the height of instrument minus my intermediate site, or an elevation of 189.38 feet. Now I'm not going to move the instrument now, so I can simply move on to my next location, which is station 0 plus 50. And my computer's a little bit sensitive here, I apologize for that. 0 plus 50. And again, we have another intermediate site. In this case, it's 4.30. And we can determine the elevation here as 193.8 minus 4.30, or 189.50. And again, from a logical perspective, this is only the intermediate site is only 0.12 difference between 0 plus 0, 0 and 0 plus 50. Therefore, we would only see a 0.12 foot difference in the elevation at those points. Now let's move to turning point 1, which is right here. So turning point 1, now we're going to have at this location, we're going to establish a temporary benchmark and then move the instrument. So turning point 1 will both serve as a foresight to establish a temporary benchmark plus a back sight to serve as a benchmark for my new height of instrument, my new location. So right now, first I want to measure the elevation at turning point 1. So I use this as a foresight, 2.01. And I would, just as I did before, I would subtract this from 193.8, which is my height of instrument here. And so I found the elevation at turning point 1 will be 191.79. Now I want to pick up this level, move it to this new location. Now I want to look back at my temporary benchmark at this elevation. So my back sight now is going to be 5.11. And that will allow me to establish my new height of instrument right here, which is 191.79 plus 5.11, or 196.90. Now I have some more intermediate sites I can work with. Station 1 plus 0, 0 has an intermediate site of 4.66, which I see right here. So that tells me the elevation at station 1 plus 0, 0 is simply going to be the height of my instrument now of 196.9 minus 4.66, which will give me 192.24. Another intermediate site is a station 1 plus 50. And that intermediate site is 3.98. So again, my elevation now at 1 plus 50 is simply going to be my height of my instrument minus 3.98, which is 192.92. And then I can move to station 1 plus 75, where I have one more intermediate site of 1.2. So you see here there's quite a bit of slope between, and there's 25 feet between station 1 plus 50 and 1 plus 75. And now my elevation at 1 plus 75 is going to be 195.70, which again is my height of my instrument minus my intermediate side of 1.20. And now finally I'm given turning point 2. And in this case, this is a turning point. We would assume I'm going to establish this as a new temporary benchmark. So my force side at turning point 2 is 1.80. And that gives me an elevation at turning point 2, of 196.90 minus 1.80, or 195.10. Now, if this was a true turning point, I would have now moved this instrument again down this way and moved on, but it doesn't show me this in the figure, so I can stop here. Now, let's do the arithmetic check, and we can look at the sum of the four sites is simply, I'm sorry, it's the wrong spot there. The sum of my four sites the sum of my back sites, I'm getting ahead of myself. The sum of my back sites is going to be 9.83 feet. The sum of my four sites is 3.81 feet. So if I subtract the two, 9.83, I'm going to kind of put a line here to kind of differentiate this. 9.83 minus 3.81 gives me a change in elevation here of 6.02 feet. And again, you see here, I've gone uphill, and I've increased my elevation a little more than 6 feet. And if I look at my elevation values here, I find the difference in elevation between my last point and my first point is 195.10 minus 189.08, and that is 6.02 feet. So I check. Okay, so again, I want to emphasize a couple of things. Number one is try to resist the temptation to simply plug through this through memory and what you read in the book. Make sure this makes some logical, physical sense to you. Check your work. When you see here in this diagram, I'm clearly moving uphill as I proceed from my first benchmark up to my turning point 2, and this should be reflected in the elevation values that I see here in my table. You would be amazed how many times someone gets turned around and the elevations that they're calculating are actually going the wrong direction from what's physically happening. So make sure you're doing this logical check, and that should serve you well. So again, this is example 2 from the third lecture. I hope this helps you better understand differential leveling. And as usual, if you have more questions, you can email me, come to office hours, or try to schedule another appointment. Thanks.